This question is about an electric circuit. You have a filament lamp which is rated at 12 volts, but it will just light up if the voltage across it is 6 volts. So that's what you need for it to light. A student sets up an electric circuit to measure the IV characteristics of the filament lamp. In the circuit shown below, the student has connected the voltmeter and the ammeter incorrectly. Okay, so the first thing to identify in this picture is where is the incorrect connection, and you should be able to see that it's here. Okay, now it's incorrect because we're trying to find the IV characteristics of the filament lamp. Okay, so it should be in parallel with the lamp. Okay, but it's not, it's in series. The question then goes on to say that the battery has an EMF of 12 volts, okay, and negligible internal resistance. So this is not a question about internal resistance, you can forget all about that. The ammeter has negligible resistance, so you can ignore pretty much the effect of the ammeter, and the resistance of the voltmeter is 100 kilo ohms. The variable resistor here, now let me explain a little bit about what that's used for. This is to create a potential divider circuit. Now if you remember from a potential divider circuits, what you're doing is you're siphoning off, you're trying to get some of the voltage away from the circuit into the bulb. So if we do the following, and that's connect the slider in the lamp up here, then what you're doing is you're taking the entire potential difference across this entire resistor and you're giving it to the lamp. So if this circuit was working correctly, and that means ignoring this business and this business, what we would have is 12 volts going into the lamp. But that's not the case. What's actually happening is that we have an extremely high resistance. So if we think about the circuit that's flowing, you have current flowing through here, through part of this resistor, through the 100 kilo ohm resistor and through the light bulb, and then back to the 12 volt battery. Now we have 3 resistors. We've got this one, which has a maximum value of 15 ohms. We have this one, which is huge, 100 kilo ohms, and then we've got this one, which needs 6 volts. Okay, assuming it would get it. Now, those 12 volts EMF that's coming into the circuit will be distributed amongst these 3 resistors. But remember, voltage is proportional to resistance. So the bigger the resistance, the more potential difference. Now this one is not just bigger, but it is massively bigger. So most of the 12 volts would go to the 100 kilo ohm resistor. And you would get very little voltage across the light bulb and very little voltage across this resistor. So where it says explain without doing calculations whether there is a position of the slider at which the lamp will be lit, the answer is no. Because even if the slider is providing a huge 15 ohm resistance, it is nothing compared to the resistance of this section. Estimate the maximum reading of the ammeter. The maximum reading of the ammeter would be the highest possible value. And the highest possible value you would get would be if the current only goes through this first resistor. Now this resistor has a resistance of 15 ohms. Okay, so the potential difference if it was just distributed along there would be 12. So V over R gives us a current of 12 over 15, which is equal to 0.8 amps. Now this question is a lot easier, which is quite strange. Normally the third part is the hardest, but it's just asking you to complete the circuit diagram showing the correct position of the voltmeter and of the ammeter to determine the IV characteristics of a filament lamp. Now, they would require you to still use a very similar setup with the sliding resistor. Now, there are many ways to do this. This is the easiest. So here is your slider, and what this would do, would this create a varying potential difference, okay, because you would move the slider up to the top or down to increase or decrease the potential difference, exactly the same way as a potential divider. But then your circuit bulb would go here, and then your voltmeter would have to be in parallel, like that. Now the ammeter needs to be connected in such a way that you know what the current will be flowing through the bulb. So it should be somewhere along this branch. So anywhere along here would be fine. And I'll just shove it in there to pair up with the mark scheme. Okay, so that's your ammeter and that's your voltmeter.